Okay, linear in a graph is straight line. So linear is straight line in a graph. Your line has to be straight, okay? In a table, it means you're going up by a constant rate, and we're going to talk about that here in a little bit. We're going to talk about linear and nonlinear today. But I'm going to take it a step farther, more than just nonlinear. We are going to have to tell me what it is if it's nonlinear. Okay? So it's not just going to be like, oh, it's nonlinear. Well, then what is it? Are you guys done with your own conversation over there? Good, because next time I catch it, you're out. All right, here we go. So make sure you have this. You need a calculator today. Very important you have a calculator. What I want to show you right now is I want you to hit -3 squared. So -3 squared. And then hit enter. What does your calculator say it gives you? -9. Is that true? -3 times -3. Is that -9?
No.
Negative times a negative is a positive. So is this right? No. When you are multiplying the base as a negative, you need to make sure you put that base in parentheses. So parentheses -3, end parenthesis, then square it. When you do that, what do you get? 9. So anytime this base right here is a negative, you need to make sure that you put it in parentheses. So if we jump down to -1, we're going to put -1 in parentheses and then hit square. What do you get? 1. What is 0 squared? 0. What is 1 squared? 1. What is 2 squared? And 3 squared? 9. When you're squaring something, it just means that number times itself. So 3 squared, 3 times 3, 9. 2 squared, 2 times 2, 4. 1 squared, 1 times 1, 1. So squared just simply means that you're multiplying it by the same number. Okay, what they're then asking us to do is to take this table and graph it. So we're going to go over here. It says -3, so I'm going to go over to -3. Yep, you two can quit that too. And then it says go up to 9. So I go over -3, up 9, and I put a dot. Then it says -2, -2, 4. So I go over to -2, up 4, put a dot. Then it says over to -1, up 1, put a dot. I'm then at 0, 0. 1, 1, 2, 4, and 3, 9. And we're going to go ahead and connect those points. Okay, this is called a quadratic function. So I want to take a look at some things. What do you notice about how the graph looks? Does it kind of resemble like a U? I remember quadratic, the graph looks like a U because quadratic has a U in it. Okay? Now I want to look over here. What do you notice right here?
The same?
Is it like a mirror image?
Yes.
Yes. So a quadratic function has a mirror image. And then the last thing I want you to look at is I want you to look at the equation. This 2 is in what we call the exponent. What's the x located in? We call that the base. So in the equation, the x is in the base. Okay, the next one we're going to look at is called exponential function. So go ahead and grab that calculator again. We're going to start with this table. So you're going to type in, we're just going to start here so you can see where this comes from. Notice my base is 2 this time. X is representing my exponent. So we're going to hit 2. And then that caret button, which is that arrow button right here. So hit 2 caret. Be doing this with me. 2 caret. And then we're going to hit -3. Do you notice you get 0.125? And we're going to try it again. 2 caret -2. 0.25. We're going to jump down to 0. I want you to hit 2 caret 0. And what do you get? 1. Anything to the 0 power is 1. 10 million to the 0 power, 1. Anything to the 0 power. Okay, now we're going to do 2 to the 1st power. What do you get? 2 to the 2nd power. What do you get? 4. 2 to the 3rd power. What do you get? 8. What I want to point out here with this table, all you're doing every time is multiplying your previous answer by your base. That's the same as that exponent. Do you see that? Exponents is just multiplying. If I say 2 to the 3rd power, it's just 2 times 2 times 2. If I say 2 to the 4th power, it's 2 times 2 times 2 times 2. So exponents is just multiplying. And by adding one more exponent, we're multiplying it one more time. Let's graph this. Now, is there any way that I'm going to be able to get -3 and 125 thousandths exactly? No. Okay? All right, so I want to zoom in. Am I zoomed in enough? Yes. Okay, so I'm going to go over to -3, and I'm just barely going to go above the line because it's 125 thousandths. Okay, now 2. Negative 2. I'm going to just go a little bit higher up. Not much. Then negative 1. I'm just going to go a little bit more. Then finally, when I do these, can I get these exact? All right, I want you to finish out that graph. What do you notice happened with our graph? Did it kind of curve up, you know what I mean? It just slightly curved. This is called an exponential function. All right, an exponential function. Where do you notice the x is in our exponential function, in our equation? The x is where? It's in the exponent. Doesn't that kind of make sense? An exponential, the x is in the exponent. Exponential, x is in the exponent. Kind of makes a little bit of sense. Okay, let's talk about this. So just like I said before, today's CO5, I can determine if a function is linear or nonlinear. If it's nonlinear, you're going to have to tell me what it is. Okay, so let's take a look down here. Do you notice how this is saying all plus 4? Do you see that? Okay, if it's going at a constant rate like that, that is linear. Take a look at this too. What form is that in? Y equals what? What's that form called? Yeah, y equals mx plus b, but what's the form called? Slope. Close. Intercept. You really need to remember that slope-intercept is y equals mx plus b, because on ISAS it'll say, which one is in slope-intercept form? Well, if you don't know what slope-intercept is, are you going to get that right? ISAS is one big vocabulary test in my opinion. You don't know what slope-intercept is, which is a vocabulary word, are you going to get the answer right? Yes. Probably not. Okay? Y equals mx plus b is always linear. If we're going by a constant rate, it's always linear. Over here, what do you notice is happening right here? It's a mirror image. So is this linear or nonlinear? This is nonlinear. And if it's giving me a mirror image like that, what is it? We just talked about it today. We said it's nonlinear. So if it's giving me a mirror image like that, what is it? Look where my x is too. X is in the base. It's quadratic. Because if you look back at what we just did, guys, remember when it was giving me a mirror image and the x is in the base? It's quadratic. So when your x is in the base, it's quadratic. I don't know why it keeps doing that.
This is on your video, like on YouTube.
That's weird. That's the first time I've seen it. Okay. All right, let's go to the next page. What I want you to decide right now, just try it. Try to determine if you think this is linear or nonlinear. That's all I'm asking you to do. Don't list if it's quadratic. See if you can determine if it's linear or nonlinear. Okay, let's just look right here. What are you going up by? Or down, I guess. 3. The whole time, did you minus 3? So it's a constant rate. Constant rate doesn't always mean you have to be going up. You can be going down too. So the thing with linear is that you have to be adding or subtracting. So what would you say? Linear or nonlinear? Linear. Okay. What's happening here? So here I added, then here I added, then here I added, and then 5. Is this linear? No. Because am I going by a constant rate? No. Did I keep it? I hope I kept it. I don't think I did. I must have thrown it away. Poopers. You can see that too if you graph it. It just so slightly starts to curve. Just ever so slightly. Okay. All right. There's one form of nonlinear that we haven't talked about, so we're going to talk about it now. Quadratic, we've already talked about. Okay? Quadratic. The x is in the base in the equation. Now I'm going to give you a table, a graph, or an equation, and you're going to have to tell me linear, nonlinear, and what is it. So you know by looking at a quadratic function, the x is in the base to the exponent. It makes a u in your graph, and then in a table. The table is a mirror image. I would be writing this down. Okay. Exponential. It starts off slow and curves. The x is in the exponent. And with a table, we are multiplying by a number. And last one that we haven't talked about, inverse variation. Notice it's got two words, right? Inverse variation. How many graphs do you see? Two. That's how I remember it. It works for me. So inverse variation has two graphs. The other thing to know about inverse variation is the x is in the denominator. If the x is in the denominator, it's inverse variation. Doesn't matter what the top number is. Does this all make sense? This would be a very important page to keep. Questions? You're going to want to make sure you get that from somebody or watch the video. Okay. So here we're going to start off. These are exactly how my directions will read. Determine if each table, graph, table, or equation is linear or nonlinear. That's our first step. If it's nonlinear, identify the type of function, quadratic, exponential, or inverse variation. That's exactly how my directions read. You will use this stuff next year in exponentials in science, math. You'll actually use exponential this year in science here. Linear, nonlinear? Linear? Non-linear. Remember, linear in a graph has to be a straight line. So it's kind of making a U. What is it? Quadratic. B, linear or nonlinear?
Yes.
Is it straight line?
No.
Non-linear, not a straight line. How many graphs are there?
Two.
So what is it?
Inverse variation.
Inverse variation. Let's go down to C and D. I'm going to pretend like this one's not even here. How do I get from here to here? How do I get from here to here? Think of a different way. Notice I'm starting off really small and I'm getting big. Multiply by 3. If I start off really small and I get big quick, this is nonlinear. What is it? Exponential. And you can look at it this way too. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. All right, our last one, D. Linear or nonlinear? Linear. How do we know that?
It's a slope-intercept.
It's slope-intercept form. And what do we say about slope-intercept? It will always be what? Always be linear. Slope-intercept will always be linear. All right, go ahead and flip it over to the back page. You guys are going to try this now. I want A, B, and C. We'll see. All right, let's talk about this. Notice where my x is.
Yeah.
Is it linear or nonlinear?
Non.
Nonlinear. So what is it then? Where?
Quadratic.
Quadratic because the x is in the base. All right, B.
Non-linear.
Nonlinear.
Exponential function.
Exponential. It starts off slow and increases big, right?
Yes.
How'd I get from each one of these?
Let's do
So what is this?
linear. Quadratic.
Nope, just linear. If it's nonlinear, then it's quadratic, exponential, or inverse variation. All right, what do we think? Not too bad?
Easy.